Hey girls, so last class we got started with graphing quadratic functions. So this is what your notes look like from last time. I'm going to go through and finish them up so that you can watch this on your own time so we can have an enjoyable day today at the carnival with the other IB classes. So we are down to this example and we are going to figure out how to graph this. I highly recommend that anytime you have to graph something that you put it into your graphing calculator. You will be able to use your graphing calculator on all portions of your IB exam, so we might as well learn how to use it. So I'm going to type -3, x plus 2, and then x minus 2, and see what happens with my graph. There we go. In order to get a specific graph, we need to go to the table and find points to plot. And then we're going to do what this says and find all of these different pieces of information. So to go to the table, we press second graph, and I'm going to plot some of these points. Anything that fits or closely-ish fits on my graph. So I've got -2, 0, -1, 9, 0, 12. It's a little bit off my graph. I'm going to go ahead and mark it. 1, 9. Seems like we're headed back down now, and 2, 0. So my graph looks about like that, okay? So we're going to answer each of our questions. So the first question is, what is the y-intercept? The y-intercept will always show up in your table. It's whenever x is 0. So 0, 12 is where this is crossing the y-axis. It's all the way up there. The next thing at once, let's see, x-intercepts. So we've got x-intercepts. X-intercepts are our points where we're crossing the x-axis, so here and here, and we just list those points. In this case, they are nice whole numbers, so we just write them down. We've got -2, 0 as an x-intercept, and 2, 0 as our other. Then we need to find the vertex. So vertex. Vertex is our turnaround point. In this case, this is a maximum point. If you imagine this as a mountain that you're walking up, this is the maximum height that you would reach. An example of a minimum point is the first example at the top of this page. Okay, lowest point that you reach. Our vertex here is also a nice whole number that showed up in our graph, and it is 0, 12. Same as our y-intercept in this case. Our axis of symmetry is the vertical line that goes through the vertex. Which will be at x equals 0. As a reminder, the axis of symmetry is the line where the graph looks the same on both sides. So if I were to fold along the orange line, it would match up on both sides. Everything would match up. Then we have to do concavity. It's either going to be concave up or concave down. It has to do with the opening of the parabola. The opening is facing down, so we say it's concave down. For all quadratic functions, our domain is all real numbers. So you can either say interval notation as -∞ to infinity, or you can write it in set notation with the little squiggles, all x such that x is a real number. And lastly, we have our range. Our range does change with quadratic functions. For this, since my arrows are pointing down, the lowest that it gets is -∞. It goes all the way down with these arrows. But the highest it reaches, it does not get above 12 for my y's. So for my y's up and down, the lowest it gets is -∞, and then it reaches up to 12, but no higher. So in interval notation, -∞ to 12 is my range. And in set notation, we have all y such that y is less than or equal to 12. Okay. I'm going to flip to our next page. Feel free to pause at any time that you need to stop and write down what I'm working with or think about it. So we're on the back of the page now. Mine's stapled, but this should say factored form. So factored form looks like this, and that's how we graphed over here. The nice thing about factored form is we can quickly find our x-intercepts. So we have an x-intercept that goes along with each of our factors. So we look at what would make this factor 0, and we get an x-intercept of -2. What would make this factor 0? Well, 2 minus 2 is 0, so we get an x-intercept of 2. So whenever we look at factored form, the a value, a controls concavity, and how wide the function is. P and Q each factor produces a 0 or x-intercept. So we'd look at what makes each factor 0, and that's going to give us the zeros of our function. So P and Q in this case. So if we look at our next example, I'm going to try to graph some stuff about it without using my calculator as practice. So if I look at this factor, the value of x that would make this factor 0 would be x equals -2, because -2 plus 2 is 0. The value of x that would make this factor 0 is x equals -6. This tells me that my graph will cross the x-axis at -2 and at -6. Additionally, I can find the vertex from here. So because I'm crossing the x-axis at these 2 points, I know that my vertex has to be directly between them. In order for these to fold and match up, my axis of symmetry has to be right there, so that if you were to fold, your x-intercepts would match. So directly between -2 and -6 is -4. So my axis of symmetry is x equals -4. We also had our x-intercepts already as -2, 0, and -6, 0. So we're right on track. In order to find my vertex, I know my vertex is along the axis of symmetry, and I have an axis of symmetry that's x equals -4. So without using my calculator, to find the vertex, I can plug -4 into the equation, into the function, and find the y value that falls on my axis of symmetry. Or we can use our graphing calculator. So I'm going to go to y equals at this point, and I'm going to type in my function. So I've got 2 parentheses, x plus 2, and then x plus 6, and graph it. We can see that we are crossing the x-axis at the 2 points that we thought, so -2 and -6 we are crossing, and we should, in our table, be able to plot a couple additional points. So for instance, -3, -6, -4, -8. That's going to be my vertex. And then we have -5, -6. Well, let's see if -1. -110 still barely fits, and we'll have its symmetric point over there as well. So this parabola looks like that. If you want to find the y-intercept, this is off our graph, but it's right here in our table. Additionally, this is concave up, and we're going to stop there on that one. Down at the bottom, it just wants us to find the vertex. So you have 2 choices for this. You can type this into your graphing calculator and identify the turnaround point from your graph. That is a great method. I'm going to try the algebraic method. This is in standard form, which is our distributed out form. This is in the form of y equals ax squared plus bx plus c. In order to find the vertex, or the axis of symmetry, we use this formula, -b/2a. This is the only formula that's in your IB formula book for this topic. So you will have this available to you. And we plug it in. My b value in this case is 10, so negative 10 over 2, and my a value is 2. So my axis of symmetry should be at negative 10 over 4, which is negative 2.5. So my axis of symmetry is x equals negative 2.5. In order to find the vertex, we take that value, plug it back in, and that gives us the y value of our vertex. So if I take y equals 2 times negative 2.5 squared plus 10 times negative 2.5 minus 3, I should be able to type that in and get my vertex. Negative 2.5 squared plus 10 times negative 2.5 minus 3. Ta-da! I get negative 15.5. So it wanted us to find the vertex, and that is at negative 2.5 and negative 15.5. Okay, I'm going to stop there. I'm going to skip this example. You guys should have your homework that I gave you last time that you can get started on. You had a worksheet, and then I gave you some additional practice problems from the book. Thank you for watching, and please ask me any questions that you have during class. I am happy to help, but hopefully this can keep us moving forward while also working on our paper and having an enjoyable day with the other IB class.